In this video, we're going to talk about Java Dependency Management with Maven. We're going to talk about how to define them, where they come from, how they're stored on your local system, the various ways to define versions and manage those versions, how transitive dependencies work and how we deal with them, and the various dependency scopes. So let's get started. The project that we have here is from a previous video that I'll put in the description. And all it is just a very simple Java project with Maven already set up. It has no dependencies as of right now, and it's just pretty much a hello world application, as you can see. Nothing special. So in this Pom, we're going to add a dependency, and the way we want to add it, we're going to add a dependency on a library called Commons Lang. This is from Apache, very common tool, probably familiar with it, but if not, we're going to show how we set this up. The very first thing we have to do is put the dependencies block in our Pom, since that is not something in there by default, and then define our dependency. Well, in order to know what that dependency looks like, you might copy and paste it off a blog article, somebody else's code. But if you really want to find the latest of any given thing that you're looking for, what you're going to want to do is look at Maven Central. So in Maven Central, you can search for any given lang that you're jar that you're looking for. And what we're going to do is specify Commons Lang. Commons Lang 3 to be precise. That's what we're looking for. And in the search results, you'll find what you're looking for here. And this is the project I care about. And when you browse this, you'll see that it has all the various versions. And one of the nice things that this gives you is when you click on a version, it will show you the exact dependency XML that you need to copy and paste. So let's go ahead and do that. We'll just go ahead and copy that, paste it into our project, and save. And what we're going to see immediately in IntelliJ, this will happen in your other IDEs as well, NetBeans, Eclipse, of course, as long as they have Maven enabled and they understand a Maven project. This automatically auto-imported and added this Commons Lang 3 jar to my project as an external dependency, because that's the way it works in Maven. It's not actually in my source code. So what really happened here? Well, if we take a look, we can look at the command line and see what's going to happen if we perform the Maven compile. Let's do a Maven compile and see what it wants to do. So it went ahead and compiled, and nothing special happened because it already had that jar downloaded. So we don't really see the action of that. So that brings us to well, where are they stored? As you can recall from the previous video, Maven is handling all the class path information for us. So the jar itself doesn't actually have to live in our project. And that's one of the really nice things about Maven. It just has to be cached locally somewhere so that it can find it. Well, that by default is going to be in the Maven home. It's going to be in your local home directory, the .m2. So if we go take a look at that directory, let's go to .m2. There is a repository directory under there. And all this is just a giant file system that is a cache of all of the various jars that you've downloaded. So if we look at this particular one that we were trying to point at, they had a group ID of org.apache.commons and an artifact ID of Commons Lang. Well, under this repository directory, we're going to find that there's a directory structure that matches the group ID. So if we navigate, we can go to org, Apache, Commons, Commons Lang 3, and if we look in this directory, we're going to see all of the versions that I have cached locally. Now I have lots of versions of Apache Commons Lang 3 cached locally because I've just been doing various Java projects over time, and they just get downloaded with various projects and through transitive dependencies. So I happen to have 3.9 here. Now, what I'm going to do is I'm going to remove this. I just want to delete it off the file system. So let's just completely remove the 3.9 version from my file system. It's no longer there. And if we go back to our project, that's not going to get me there. There we go. Go back to our project, and we perform that Maven command again. We're going to see something new. And this time what we see is it went ahead and it realized that it didn't have that version of the jar downloaded locally in the cache, so it had to go fetch it. So this time it actually went out to Maven Central and downloaded that jar. And if we go back to the directory we were in before, we will see that it's actually in that directory now all over again. It just downloaded it and put it back in place. org Apache commons lang 3, and we can see the 3.9 is there again. So that's a quick rundown of where dependencies come from by default, how you define them in your POM file, and where they go and when Maven's going to fetch them. So that brings me into the next topic, which is talking a bit about the versions. So as you can see here, we specified a concrete version 3.9. Most of the time in Java projects, you're going to find that that's the way everybody defines things. But if you come from a different language or another ecosystem, such as the Node ecosystem is the perfect example, you'll find that people don't define their versions that way. They usually will define them in some sort of range, with range specifiers to say that I don't really care which version it is as long as it's this level or this minor revision. Well, we can do the same thing in Maven. And I'll show you an example of those ranges here. On this page, the Maven Enforcer built-in rules, we have access to these different ranges. We can specify all of those different loosey-goosey requirements if we want. But from my experience, I find that this is actually really bad practice. Unfortunately, we find that a lot in different communities, but we don't find it in the Java community very much, thankfully. If you've ever worked on a project and you understand what unstable builds are, you'll know why this is so important. Locking down your versions is something that's really critical if you want to have stable builds. Now, that said, I think it could be really positive to have, let's say, another branch of your code that's building on a regular basis, maybe daily, and you specify like range versions like this so that you could maybe know automatically if your code is going to break or your project is going to break with a new version that comes in at a time that you're not aware of. I think that that would be a really nice thing to set up. But I think in general, for safety and build stability, you really want to stick with specific version numbers so that you don't get surprised by updates that happen when a new version shows up. As far as versions go, you can pretty much specify anything. They're arbitrary. The only thing that's really special in Maven is a particular suffix called -snapshot. We talked about this a little bit in our previous video, and the -snapshot suffix is a signal to Maven to know that this is a dynamic app. It's not set in stone. This is a development version of code that's going to update from time to time. And so the -snapshot allows us to specify this and say, I really want 3.9. This is really good if you're working on development dependencies, things that are in active development and still in a snapshot version. You can get those updates all the time as they come. And that instructs Maven to always remotely look and see if there's a new version by timestamp of this particular version of the code. So the -snapshot is actually a really special suffix that means something in Maven. Otherwise, everything else is considered to be a quote-unquote release version. Even if you call it .m1 for milestone or RC2, it doesn't really matter. As far as Maven's concerned, that is just a released version. It won't update and it will not behave in a snapshot manner. Once it's been downloaded, it's going to say, I have this version, and it's not going to look for new ones anymore again. So that's something to keep in mind in particular. This is what I would call a standalone or isolated dependency. If we look at this particular dependency and what happened in our project, the only thing that came in was this one jar and this one jar alone. That's because it's a standalone jar. It has no other dependencies that it needs to do its work. If we bring in something else, a perfect example would be a Spring library. And what I'm going to do is I'm going to use the Spring Boot Starter web app. You might be familiar with that with let's see, Spring Boot Starter web. And I'm going to use the latest release of 2.2. So let's see how this changes our dependencies and what the transitive dependencies look like. I'll copy and paste this, and I'm just going to bring this one particular dependency in, replace the one that we had. So now what we're going to see happen, if we look at IntelliJ, since it understands, we have a lot of jars now. We only define one dependency, but look at all of the stuff that came in. Those are called transitive dependencies. And looking at this view, it's pretty much impossible to know where they came from. Thankfully, something that we can do on the command line that makes this very easily is just use a built-in command to look at the dependency tree. So if we look at Maven W dependency tree, we can get a nice output of our dependencies and where they came from. So now this becomes a lot more powerful to understand where a particular logging framework or where a particular jar of any sort came into your project and why you have it. Why is this thing on the class path? Is you can look at the Maven dependency tree and see where they came from. So now if we were questioning, how did I end up with logback 13123? Well, now we know that logback came through the logback classic jar, which came through the Spring Boot starter logging jar, which was brought in through the Spring Boot starter jar, which is brought in through the Spring Boot starter web. Now, what's neat about this is that through transitive dependencies, you see that I simply define one dependency that is Spring Boot starter web, and I, by default, get all of the things that it needs to operate. This isn't really new. This is something you might be familiar with other package management systems, but it's something to keep in mind that this is how this works. Which now brings me into the next topic, which is how do I manage those transitive dependencies? Sometimes you might want to override a version of a jar is bringing in. That can be as simple as just specifying another, let's pretend I want another version of logback. And so what I could do is define my dependency, and I can really just look here to see the version that I want. Here is the group ID. So let's use that. And then here is the artifact ID. And then I'm going to actually specify a different version. So it's bringing in 1, 2, 3. Just for giggles, I don't know if this exists, but we're going to try 1.2.2. I imagine that's a real version. So sure enough, we got 1, 2, 2. And now if we look at the dependency tree again, and in fact, let's look over here. We'll see in my dependencies, I now have 1, 2, 2, which is good because I overrode what was there. And if we look at the dependency tree again, we'll see that now logback 1, 2, 3 no longer comes through the starter logging jar dependency transitively. Maven figured out that we're trying to declare it explicitly ourselves at the high level. So now it comes in as a direct dependency of our project at the version that we specified. So that's a real easy way to override a particular version that's coming in transitively. Now let's say you wanted to remove it altogether. Let's say that particular jar was coming in and causing problems in your project and you really don't want it there at all. Well, there's something else you can do, which is just exclude downstream dependencies. This is another, you just put it as a set of exclusions in the dependency itself. And so here, you don't even have to specify the version. You just specify the group ID and artifact ID of the thing you want it to exclude, and it will remove it altogether. So let's go ahead and do that. So we'll just say I want to bring in Spring Boot starter web, but I don't want logback as part of the logging dependency. You probably don't want to do this, but this is just an example. Now, if we look over here, again, Maven or IntelliJ figured out that it doesn't need that anymore. And if we look at the Maven dependency tree on the command line, we will see that logback logging no longer is in our class path. That's gone because we excluded it. So that's really the basics of how to define a dependency, where they come from, where they get stored, how to specify different versions, and how to exclude downstream transitive dependencies. That gets us pretty far overall. All right, so now let's talk about how we deal with dependencies that are not in Maven Central. We've been dealing with dependencies that we've been able to fetch freely from Maven Central, and it's going to look there and find them, which is great. But there's sometimes when you need to use another repository to look up the artifacts. That could be, in our case, what we're going to do is we're going to actually try to use a spring.2.2 or M6. This is something that I looked up ahead of time. I know is not going to be found, but it is available. And so in this example, what I want to show is I'm going to use 2.2.M6. This is a milestone release by the Spring team. And if we look at Spring's documentation, we'll find that the milestone and release candidates actually go to a completely different repo, which makes sense because they don't want to clutter up the public Maven Central with snapshot and release candidates and milestones. So in this case, if we go back to our project and we try to use a milestone release from Spring, you might already see a hint to it here in IntelliJ. It didn't resolve anything. It's not really telling us anything right now about it. But if I try to use the compile command on the Maven Compile, we're going to see that it errors. Well, that's because it just simply can't find the milestone in the Maven Central, like we said. So now we have to define an extra repository for Maven to look up. Now we do that very simply by defining the repositories entry and then specifying the repository itself. Now I'm just going to cut and paste the Spring milestone repository from their documentation. And now save that. IntelliJ went ahead and re-imported, and all of a sudden you're going to see it found the Spring jars for M.6, the milestone releases, which is great. And if we look locally, we're going to take a look at this particular directory. We're going to see I do have the M6 locally. And so now at this point, when I perform a Maven compile, it's just going to work without fetching anything from the remote. Sorry, let's go to where I actually ran it again. And we're going to see that it compiled, there was no issues, it found those dependencies. So now you can see that's how we define extra repositories for dependencies that are not in Maven Central. This is something that you're going to do when you have your own repositories for your local company, and whatever business you work for. Chances are you're going to have some Maven repository that you have set up running there. There's many different vendors for that. Or simply just leveraging dependencies from the internet that they're coming from other repositories that are not Maven Central. So it's really just that simple. Now, lastly, what I wanted to talk about as far as adding dependencies is something that's a little bit more advanced, but it happens a lot, and you will end up running into it. And this is where you do a Pom import. So you actually import the dependencies or the dependency management from a completely different Pom altogether. This is actually quite powerful, and let me show you an example of how we do that and why we might want to do that. So let's go ahead and remove the dependencies that we have here now, and we'll remove the repositories and get ourselves back to a pretty basic project. And so now I want to talk about how we do a Pom import from another project. Now, how we do that is I'm using Spring Boot and their example in their documentation as our reference. This is something that you might run into in your own job or your own work, but you might do this in other cases as well. And this is without getting into parent Poms, because that's not what we're talking about in this particular video. We just want to talk about dependencies. This is another way to import all the dependencies and dependency management from another Pom. Spring likes to refer to this as a BOM. They actually refer to this as the BOM, or the bill of materials. And I'll show you why. If we go and look at the Pom file that they're telling us to import on GitHub, we're going to see that it's actually quite a large Pom file with versions of all kinds of projects and dependencies and all of those things defined for us. What's really powerful about this, and in my opinion, the Spring team has really just done a masterclass with Maven when it comes to how they've set this up. The entire Spring project is essentially put together, and they're documenting all of these versions of all of these dependencies that have been tested together. In any other normal project, you're kind of left to your own devices to just pick whatever version of whatever dependency you happen to be pulling in. And who knows if they really work together or not. You just hope that they do. In many cases that they will, but you just don't know. In this particular case, if we import this Pom file by doing a dependency management import as simple as this, so I can just copy and paste into our project. What I'm doing here is I'm telling my project that I want all of the dependency versions of all of those things that were defined to be imported from the Spring Boot dependencies, from their BOM or their bill of materials. When you do this kind of Pom import in the dependency management, I don't automatically get all of those dependencies. That's not what happens. What happens is I get all the dependency management and all of the versions defined for me, so I don't have to go look them up. I can just trust that whatever Spring Boot provided for me with 2.2.2.release, all of the versions that they have specified have been tested together in their test suite. And that's actually really powerful. So we don't really have to think about it anymore. So now in our dependency management or dependencies, we can do things as simple as define a new dependency, maybe like we were doing before. In this case, it would be the Spring org.spring framework. Oops. .boot. And I don't want Spring Boot auto configure. What I want is the Spring boot starter web. Oops. So I didn't define a version, and it's not, Maven doesn't automatically know how to find the latest version, but what's happening is I'm in my dependency section defining a dependency on Spring Boot Starter Web, but it's picking up the version from the dependency management section that I'm importing from Spring. So without having Spring be my parent Pom, which we haven't talked about, I'm able to actually inherit all of those dependencies automatically, which is pretty great. And as you can see, and IntelliJ has picked that up. It's found all of those dependencies that it needed. If we were curious about what version that would be, well, the version is going to match here with 2.2.2 release. It picked up all of those versions from there. Now, let's pick on maybe a different example. So now I want to add another dependency. In this case, I want to add JUnit, but I don't want to specify the version. In fact, what I would like to do is just use the version that Spring has already defined in their parent Pom, or that Pom that I'm importing with all the dependencies. So what I can do is simply define the dependency on JUnit, and JUnit's group ID is just JUnit, and the artifact ID is also just JUnit. So if I save that, and we look over here on the side, I'm going to abandon the command line for a minute just because it's a little easier. We can see that we automatically brought in JUnit version 4.1.2. And if we want to go check and cross-reference that, if we look back at the Spring Pom that we're importing, and we go all the way back up to the top with the properties, we're going to find there is JUnit 4.1.2. So you can see how you can inherit versions through dependency management. It might seem a little odd to put dependency management in your own project like this, and sometimes it is, but what is powerful about the dependency management is that that actually can come from a parent Pom. So you can have a hierarchy of Maven projects, and instead, all of these you would inherit from maybe the Spring Boot starter parent, or you could simply have your own parent Pom where you include dependency management like we did here. And now automatically any project that is inheriting from that parent automatically gets the versions defined. You don't even have to think about it. You just include the dependency that you want and you'll get the version for free. And then the parent upstream can change that and you'll get all of those versions as well. So in our case, it's pretty nice because you could at some point in a later time upgrade to a newer version of the Spring Boot, the BOM here, the bill of materials, and all of these other dependencies will automatically upgrade as well to whatever version that were specified and tested together, more importantly, by the Spring framework. So that's an example of how dependency management would work and how you can inherit versions from a dependency management, and in this case, specifically just importing the Pom. So that brings us to the last topic that I want to talk about, which is dependency scopes. We haven't talked about that yet. And pretty much all of these scopes that we've been talking about so far have just been the default scope, which happens to be compile, is what they refer it to as. So if we go to the Maven documentation, we'll see that there's actually 6 scopes available. There's compile, I just said, is the default. You don't have to specify anything. That's just what everything that you bring in as a dependency is going to be. And what that means is that it's used in the compile phase of your source and the test, and it also becomes something that ends up in the resulting class path or the jar that you're packaging or whatever packaging that you're doing at the end. The other scope that might be available is known as provided. This one, like it says here, is like compile, but it is different in that you would be relying on it in a typical J2EE container. So in the days of deploying to WebSphere or a JBoss or a Glassfish or even a standalone Tomcat, this might be the situation where you know that you're relying on certain dependencies and jars and you want to code to those and import and use those dependencies in your code base, but you're not packaging it along with your project because you're relying upon those to be provided there at runtime, if that makes sense. So a good example might be log jars. They might be database connection, like JDBC jars and drivers. It could be a lot of things like that you would be relying on as a provided dependency in those environments. If you're dealing with a modern Spring Boot application, which you might be, or at least you've heard of it, this is not something that you're going to really care about too much because you are packaging up your whole application. So it's a little bit different. Another scope is runtime. This particular one is, as it says, it's not required for compilation, but it is for when you're executing. This is like if you're doing things with reflection. It's a really good example where your code is written to use reflection against some classes. So you're not really directly depending on them in your code, but you know that you're going to need them at runtime. So that's what the runtime dependency is. And so when you specify that, again, it doesn't get put in the class path at compile time, but it does get included in the runtime, or it is assumed that it's going to be something that's there at runtime. And next we have test. This one, again, it's not used for the normal application. So these jars don't get included in the class path for your source files, your normal application source files, but they're used in the class path of the test file compilation and running. What's nice about this is that it allows you to have these dependencies, of course, for your testing, but not worry about them cluttering up your application code or ending up in the resulting packaged jar or WAR file that you end up with. These are things that are only there for test and test only. System, it says it's similar to provided. I have to be honest with you, I've never used this. I don't even know why I would use it, to be honest with you. An import is a very special case that we actually just talked about. If we go back to our Pom, where you're importing the dependent. When you say import, it's implied that you're bringing in the whole Pom and all the dependencies with it. And so that's the last one. So knowing what we know now about scopes, we know that if we're looking at this particular dependency and we're talking about JUnit, we know that this is not the way we want to import it. In fact, the way we want to import it is we want to specify the scope here. And the way we would do that is just say scope test. Now that we have brought in the dependency, it's bringing in the version from the imported Pom, but we're just specifying it at this test level. So JUnit and all of its classes will only be available at the class path for the test classes to compile and to execute. We won't be able to reference the JUnit code in our application. So that wraps up everything that I want to talk about with Maven dependencies. I hope that you were able to learn something maybe that you didn't know before. If so, please hit the subscribe button. I've got more videos that are on the way that we're going to be talking about all sorts of things. Java, Maven, DevOps, you name it, cloud. We're going to be talking about it all. So stay tuned, hit subscribe, and I'll see you next time. Thanks.